Thank you very much, Adam, for that, and it's a pleasure to be here. So thank you. What I wanted to do really is just look about what the future holds and where we can potentially see new opportunities for everybody. What I wanted to do is just start off by making the link from the past over to the future and what that actually means. So I'll come back to this a little bit later on. So what I wanted to talk to you about today, the three key things is, first of all, why lithium-ion, and what is lithium-ion? So certainly as trainers, if we can take away a golden nugget from this, then maybe use it in your training in the future, then all to the good. So why lithium-ion? Next, I wanted to look at then how lithium-ion and its design has changed the design of forklifts and how this is molding the trucks of the future. And then finally, a big ticket item is the automation and what this actually means, so certainly from an operator's point of view and also from a trainer's point of view, what this could actually mean for you guys in the future. So let's start off with a little bit about why lithium-ion. It's a big talking point at the moment. If we cast the mind back then to lead-acid batteries, we know that it's been around for more than 100 years, and it's always done a job for us, and it's provided that solution and motive power for our equipment. When we look back then in history, you'll see that, the actual concept of the lead acid battery was actually invented in the late 19th century and went into mass production in 1880, which ironically was the same year that Thomas Edison invented the light bulb. And when you look at a lead acid battery from then, it was still the same as today, which it's two plates, positive and negative, immersed in an acid and creating a current. When you look at that from where it is today, nothing's really changed in terms of the concept of the battery. It's still creating a chemical reaction. Now, as time's gone by, the differences have changed in the way that we charge and the charging technology, but we're now at this step change in society, whether we like it or not, that we're now looking for alternative fuel sources, not just from lead acid, but that can actually take over from byproducts of crude oil, such as LPG and diesel. With that step change now in the same size that was when we moved away from horse-drawn vehicles to motor cars, or from steam trains over to diesel trains. Where we are now is that step change in society that is making a significant difference. So what is lithium and where do you get it from? Well, lithium is actually the lightest metal on planet Earth, and when we talk about we need metals to create that chemical reaction, so that's a metal that delivers a higher density of power, but it's also much lighter. Now, when we look at where it's coming from, it's actually coming from the central equatorial belt. So any of the hot countries across the equatorial belt, you'll find it's available from, but the massive resource and the biggest resource globally is actually in Bolivia. And if you look at this as a dry lake bed covering the sort of size that you see here, 110 versus 100 kilometers square, if we transpose that into what does that mean if it was here, well, you can see there, you sort of from Lincolnshire right the way across to Gloucestershire, and we all know that that's quite a vast area in terms of size as a resource. When we look at what it is, it's actually a salt that's from a dry lake bed, but in terms of the resource, we're only using trace elements in lithium-ion, and it's not just in batteries, and we've all known it for a long time with our digital watches and smartphones, but when you scale it up for forklifts, we need to know that it's a resource. There's actually more lithium-ion, or wrong, there's more raw lithium than there actually is of crude oil on planet Earth at the moment, so we need to look at this as a sustainable resource for the future. And whether we like it or not, climate change is here, it's real, and we've got to take it on board ourselves, each one of us, to make sure that we are a part of that. So when we look at the future and how things have changed, I wanted to link it to the automotive industry, just to give you some ideas as to how fast things are changing. And we look at a typical, electric car from the late noughties through to 2012 look like this, through to what we all know today. And we all know that the speed of change in just these 8 or 10 years is very, very significant. And the same is happening in our world as well, in the materials handling world. So let's have a look at what it actually does and how it works for us. So we'll all know that if you look at the dotted line down here, this is the typical discharge graph across 8 or so hours for a lead acid battery. And you'll also see then that the recharge graph, it needs about the same amount of time to recharge it. So if you do want to then go for a multi-shift operation, at this point here, after 8 hours, you've now got to go for a battery change or simply take another truck or something similar. But if we look at now, when we talk about lithium-ion, lithium-ion is the only battery that recharges faster than it discharges. So now we can start to harvest power, and anything shorter than, from anything more, sorry, than around 10 minutes, we can harness that power and put it straight back into the battery. And now we've got a resource that will actually start to survive us greater over a given period. Because of the density of the electricity as well, it will last far longer. So instead of a lead acid battery lasting 1200 to sort of 1600 cycles, which is probably around the 5 to 6 year mark, lithium ion will actually, because it's a denser supply, doesn't need any maintenance, will then run for probably 7+ years. So you're going to get a far, far greater use out of that energy resource. So when we look at any opportunity here, is a great, whether it be a coffee break or when the wheels are not turning, to simply harness some energy and put it back into the battery. You could put typically around, in 30 minutes, 50% back in. So as I say, the recharge graph depends upon the size of the charger. Now, if you say to someone, how long does it take to fill a bath with water? Well, the question is, it depends on how big the bath is and how big the tap is. That's exactly the same concept when we talk about a lithium-ion battery. We don't necessarily want the biggest battery. We actually want a smaller bath, but with a bigger tap, if that makes any sense. So as we move on then, you can see some of the benefits there, that it is going to be a sustainable source that gives us a better energy density, but without any of the maintenance that's always been associated with lead acid. So let's have a look now at how this then changes the truck design when we're working with a battery that is much lighter, that develops and delivers much more power. If you take a traditional lead acid battery and you're designing a truck, you always had to wait for and work around the big box of the battery that was the bulk and in the heart of the truck, and then you had to work and design the truck around that. So here, for example, you could take a lead acid truck and put a lithium ion battery into it. But as time's gone by, what we've learned is we can actually now change the whole design of the truck and make it completely fresh. So here, for example, in 2011, Jungheinrich produced the world's first series-produced lithium-ion truck. What does this mean? That truck in that guise there is not available as a lead acid option. It is a small battery, and at that time it was 14 kilos, and the concept then was to simply take the battery out, put another one back in and send it straight back to work, and again that battery would then charge very quickly. As time's gone on, we've then continued to develop it through the range, and then in 2017 was when Jungheinrich produced the world's first series-produced lithium-ion reach truck. And what you can see here is, again, not available as a lead-acid derivative. Now look at the shape and size of that battery. If I just run a short animation here to compare the two side by side, on the left-hand side of the screen in a second, what you'll see will be a lead-acid versus the right-hand side where you've got the lithium-ion. Now, as it pans round, you'll notice that on the left-hand side, it's the battery that's forming the weight, but on the right-hand side, the weight is made up by a cast iron counterweight. Now, what this is doing is it's throwing the center of gravity much lower. Now, we all know as instructors that the lower the center of gravity, the better. Let me ask you a question. How many tall racing cars do you see? Not many, because the lower the center of gravity makes things much more stable. So then when we look at the design of a reach truck, it gives you the better visibility all the way around because you've now put the battery much farther down into the chassis. When we look to the future, we've also then in 2018 created a stand-on truck where, as a straddle leg, where the battery is not forming any part of the counterweight within this truck, and again, only available in a lithium-ion derivative. Now, what that means is that the weight is low down in the center, and you've now got a stand-up truck, which allows the operator more space to work. And again, it's just completely breaking the mold as to what we've done before. Looking ahead to the future then, a sneaky peek for you. If you look here, you can see a diesel truck. No, it's a diesel truck because you can see the exhaust stack. But if we now compare that to the new truck that Jungheinrich is producing very shortly, which is the Jungheinrich EFG P30i, exactly the same chassis, exactly the same mast. Everything is the same, but now this is lithium-ion powered. Performance numbers will be exactly the same. So now you can see, here's the truck, how do you want it powered? So looking forward, you've got there a counterweight, and you can just see on the animation there, the battery is within the counterweight. So again, completely breaking the mold as to what's gone before. So that's looking now about the trucks in the future. What we'll now look at then is about automation, because there's a lot of time now where we're talking about automation and what this actually means. We all know that we can sit there at night at home and order something and we expect it to be delivered the next day. But how does that happen? Well, I just wanted to point out that first of all, automation is not necessarily something that's new. Jungheinrich have been doing automation since 1963. So any operation over time that has always been repetitive, automation has always been there, a solution that's available for everybody. Now, we already know about a manual operation because this is somebody sitting on a truck and driving it and moving product through a warehouse. But then you have two others, which is semi-automation and full automation. So these are the two I wanted to touch on. Now, any of these automations, whether it be full or semi or even manual, people now are looking to find marginal gains within their business that can make a significant difference to an operation. So if we look at semi-automation and we consider this here where we've got a man-up order picker, we'll know that the lower they stay, they can travel fast, and as they start to lift, they then need to slow down. Or they can go up sooner and take the top line, but then that may take a little bit longer because they have to slow down. Now, what's happening with semi-automation is where you have a signal coming from the warehouse management system directly into the brains of the truck, not just to the data terminal. So what this allows now is it tells the operator simply to drive forwards and up. The truck will then take itself in the most optimum route to that pick. Now, this is marginal gains that is being saved. But the point I'm trying to make here, yes, it's semi-automation, but there is still an operator. So when we talk about full automation, people say, oh, it's the future. As I've just said, it's been around for a long time, so it's not just necessarily something that's happening today. When we look about automation is about no drivers at all, and the operation is completely autonomous. However, automation, yes, it is very effective. It's 15 to 20% of the potential market that's out there is suitable for automation. It's not going to load lorries on the yard, and it's not going to do many of the operations, but if it's repetitive and it's high storage density, then yes, it will be a solution for people. But as you can see here, what I want you to notice when you look at this video, it's still being fed by forklift trucks, and there is also manual operations around that are taking part within what is essentially a full automated site. The market currently is standing at around 35,000 units, and it's forecasted to drop by 2030 to around 26 to 27,000 units. So that doesn't necessarily mean the whole market is changing. It's probably going back to a point where it was around 7 or 8 years ago. So there's always still going to be a need for for training within a fully automated system. This could be whether it be for training either operators, people who are working it, people who need to check it, safety checks, etc. So this is still something that will need training in an environment such as this. When you then look at a typical warehouse operation and what you see here, Jungheinrich as a full range supplier can supply everything within this operation other than the lorries and the people. But what you will see is that there are still operators operating within this, even though it is shown as a fully automated system. So it's about taking marginal gains and making any change that's necessary to stay sustainable, not just today, but into the future. That brings me back to where I started. And some of you may have recognized who this fella is. Well, it's actually Charles Darwin. And it was Charles Darwin that said, it's not the strongest of any species that survives, nor the most intelligent, but it's the one most adaptable to change. And that goes for every one of us, me, you, everyone. We've all got to find those marginal gains and how we can change what we're doing to make what you're doing add value to other people. So good luck with it, and I hope you've enjoyed the presentation, and thank you very, very much for having me.